You can do a lot with peer groups. Think to possible applications, such as a lot of iBGP neighbors inside of your autonomous system needing the same exact configuration over and over and over again. Peer group is good for that. A peer group would be great from a service provider's perspective, thinking, hey, I'm a service provider and I've got X number of customers. I want a consistent policy between me and the customer, and I want to configure that easy. And the way to do that is to have a peer group say, all right, you're customer 45, and you're part of the same customer base, same configuration, same peer group as 1 through 44. But let's explore this together and look at a scenario. And the topology here is representative of that scenario. We have a primary and a backup. We want to only advertise our networks, those that we generate, and we are autonomous system 65,000. We want to accept the default route and networks that have an 8 through 24 CIDR notation mask. This is going to exclude smaller subnets, the /25 and beyond. But we also want to prefer the ISP at the top, ISP 65100. Now we can do this with a peer group. It's a little harder to do this with the peer group than just a raw config, because we somehow have to have a route map pin down routes from 65100 and assign something that would make it preferable. Local preference is going to be our mechanism for doing that. In this topology, we could probably do wait, but local preference is a little bit more realistic. Let's look at the config that would allow us to set up a primary ISP, exclude certain routes, and do it all with a peer group. So we see this peer group ISP. That's just a case-sensitive name. And we have a filter. We have a prefix list bound to this. Notice the directionality, by the way. And so the first process would be the route map, then the prefix list, and then for outbound updates, it would be the filter list. There's an order. RFP for inbound and PFR for out. And we can see that we've got two neighbors. Now, we have to understand that these both have to be eBGP neighbors. But it looks like we're in 65,000, and they're in two different autonomous systems, but they were going to impact or influence the policy in pretty much the same way. I say pretty much because you can see that we're going to treat one of these a little bit differently. Now let's dig deeper into the route map. That's going to be really the most telling of the elements here. So we look at the route map. It's called filter. You can see that here. Permit 10. And remember that this is being applied inbound. You can see that. It's being applied inbound. So what we're going to do is we're going to look for routes with a certain autonomous system path. AS path list 20. So if we look here, AS path list 20, it says those routes which are sourced from 65100. 65100, and I brought in a little legend here. Means start or ending of the string. 65100. So it really has to be sourced from that autonomous system. But we have a set command now. And the set command says 150. Local preference of 150. We wanted a primary and a backup ISP, primary and secondary, whatever you want to call it. A local preference of 150 is preferred over the default local preference of 100. So if you are sourced from AS 65100, you'll get a local preference of 150. All things being equal, that will be preferred. And then the second sequence here is permit any. Allow the rest. We don't want to filter anything else. Okay? Now, let's move on to desired subnets. It's a nice little prefix list that we've got baked in here. So desired subnets in. Which subnets will we receive? We will receive the default route. That's the default route. And any route with a subnet mask greater than or equal to 8, but no larger than 24. So that's the appropriate subnet mask spectrum of received routes that we will accept. Okay. So what is the effect of that combination? It says if you are coming from 65/100, we'll give you a local preference of 150. That's the preferred ISP configuration being applied. And then make sure we don't get more routes than we want. Default, and then this range that we've specified here. So that accounts for the majority of the configuration. There's one more thing, a filter list, which references AS path list, access list 10. And it says permit where the AS path list is smushed together. Start and end have no gap, no room. Nothing can exist here. It is the void. And that is saying routes that we source from the local autonomous system, because there's nothing in between the start and the ending of the string. Notice the directionality. That is in the outbound direction. So because it's in the outbound direction, it's saying only advertise to these two peers routes that we source. And so if we look back to our scenario, I think we've gotten the job done. We are Gateway 1. We wanted to advertise only networks originated by the local AS. So we accomplished that with the AS path list. Accept the default route in networks with a subnet mask of 8 through 24. We got that done as well. And then prefer the primary ISP, which we accomplished by setting the local preference of all of their routes to 150. Peer groups made it a little bit easier, arguably, but don't mistake the main purpose in life for a peer group, which is to reduce the overhead of BGP on your routers by only having to perform the calculations once per peer group.